8 live session, and I am giving you the overview of week 8 and some of the concepts regarding that, and how to solve the questions properly using mathematical analysis. So, I will be happy to teach you today. And if you have any doubt, just let me know. Stop me anywhere. I'm waiting for 2-3 minutes for some more students to join. And okay, see you soon. So week 8 was basically not very tough week, but yes, we will see how to solve the questions. I will just start with introduction, the key property, so that you will memorize it. Remember it. We'll start in 2 minutes. Just waiting for some students to join. Okay, so welcome back, everyone. I hope you all have gone through this particular week lectures. If not, don't worry, sit back and relax. Here we will be going through the concepts to solve the problems. Okay. So basically, if we talk about the introduction to Laplace transform property, we have the formulas. This L of ft is equals to 0 to infinity ft e power minus st dt, where ft is defined for t greater than equal to 0. Otherwise, it will be minus infinity to infinity. Okay. So key property, as we know, we have already discussed in the last class. So it is a linearity, it is a time shifting, it is scaling in time. So if we talk about what is scaling in time, so L of FAT is equals to 1 upon A, F of SA by A. Okay. If you talk about, it's giving you that if your function at a time it's shifted by this t is equals to t minus t naught, then it is multiplied by e power t naught. If you have e t naught s, then f of s minus performance. Okay, so the performances. Okay, it will change the performances of this particular Laplace transform. Okay, how basically thing. So it is always an advisory thing to do check it here with the property. So there are some examples which are the linearity example. Okay, so for example, you have ft is equals to 2 e power 2 3d. I think don't think my performances are not changing here. Okay, still. So you have ft is equals to 2 e power 3t, and you have gt is equals to sine 2t. Now, let's suppose you have function as alpha ft plus beta gt, where alpha is equals to 2, beta is equals to minus 3. Now you have to forget the performance of this system, because this system performance will depend on the FT system performance and GT system performance. So what is your advice? What will you do here? You cannot have a common form here and find the Laplace transform of that closed form equation. Okay, what it is always an advisory thing to follow this linearity property in that case. So how to solve that? Let's see. E power 3t, here it is 2 uh, 2e Laplace transform of ft minus 3 Laplace transform of gt, whereas L of e power e 3t is equals to 1 upon s minus 3. By default, it is multiplied by 2ut. So don't get confused with that, because if ut was only involved, then only it will be the case. Otherwise, we are changing the definition itself here. Okay. So by default, the ut is multiplied with ft. That changes. Okay. Now you have to just substitute here and you will be getting this. Okay. Now let's say some time shifting concept. Uh, Find the Laplace transform t minus 2, t ut minus 2. So as you know, the Laplace transform of ft is equals to t is nothing but fs is equals to 1 upon s square. Okay. By formula also you can find. So let me solve for you. Or what will be the Laplace transform t? So minus infinity to infinity. It's not obviously t, it's tut. So minus infinity to infinity, tut e power minus st dt. So since ut is there, so 0 to infinity e power minus st dt. Okay. First function, second function, wala formula will be applied here. So first function is this one, 0 to infinity e power minus st dt minus differentiation of this function, and yeah, differentiation of this function will be multiplied with integration of this function. So if you solve it, you'll get it 1 by s squared. The formula you have to see, I am also forgetting it here. Okay. So simply if you have this 1 by s squared, then here it will be multiplied by e power minus 2s into 1 by s squared. That is showing that you have shifted in time domain. Shifting example with exponential series. So example problem, suppose you have is ft is equals to e power 2 tut, and find Laplace transform of ft minus 1 ut minus 1. So in that case, it will be just multiplied by e power minus s and 1 by s minus 2. Yes. So answer is that only. Because e power minus s, because it is a is 1, so e power minus as multiplied by the same Laplace transform. So suppose you are given only this, the s domain function. In that case, what will be your? Oh, I think my mic is not working properly. So yeah, if you are given in the s domain your exponential term, then you have to find it out that it is like the addition, it is the shifting property in the time domain. Okay. Okay, scaling property. Using this scaling property, calculate sine of 3t. So we know the scaling property, what is that? It's L of f of at is equals to 1 upon a f of s by a, as we know. Okay, so if ft is equals to sine of t, then f is equals to 1 upon s squared plus 2, isn't it? As we know, 1 upon, it is actually sine 80 Laplace transform sine 80 is a divided by s squared plus a squared. Laplace transform of cos of 80 is nothing but a s divided by s squared plus a squared. So find sine of 3t. Find sine of 3t. Anyone? Please write in the chat box. Please write in the chat box. There's some issue with my mic. I had tried over clicking on that, but I don't know if that why it came or not. But yeah, so answer will be nothing but 1 by 3 s by 3 whole square plus 1. Suppose you have this problem. Combined example, Laplace transform of 2 power e power 3t plus t minus 1 u power t minus 1 minus 4 sine 2t. Please take a moment and try to find the solution. I will give you the detailed solution in just 1 minute. So detailed steps, I hope you have all got the answer, but detailed steps are listed as like this. So Laplace transform of 2 e power 3t is equals to 2 into 1 upon s minus 3. And similarly, why it is 2? Because 2 is just a scalar, so it will come out. Okay. And 3 will is again a scalar, it will come out. And t minus 1 is leading to e power minus s. And t minus 1, tut has a Laplace transform 1 upon s square. So that's why it's 1 upon s square. And Laplace transform minus 4 sine 2t. So 1 upon 2, it will be here. So wait, all this I'm calculating. Minus 4 will be here only. 1 upon a 2 divided by s square. So this s by a, s s by 2 square plus 2 square 4. Okay, so it is minus 4 to s square 60, and it will be going to 4. So yeah, answer is wrong here. Thank you for commenting in the chat box. Mm. So basically, answer is wrong here. Minus 4 will go here only, but sine 2p. Acha, acha, acha. Yeah. So wherever this Laplace transform of ft is there, but you don't know the Laplace transform of f of at, then in that case, this formula will be applied. But if you already know this Laplace transform of sine at, then no need to apply this f of at again. It will be a wrong case here. So sorry for my doubt. So it's correct here. It's minus 4, 2 divided by square plus 4 square, 2 square. So summing it up, we'll have this. So key takeaways are the linearity allows direct transformation of some scaled functions. Shifting in time introduces a multiplicative factor e power minus t naught s, whereas scaling in time rescales the transform argument. Absolutely. Okay. Advisory performances. You will have this thing. Let us have some derivative properties over. So first derivative property is Laplace transform of f dash of t is equals to sfs minus f naught of 0. Whereas second derivative property is a Laplace transform of f double dash of t is s squared fs minus sf of 0 minus, like it is an initial condition. Okay, whereas you have Laplace transform of integration of ft is giving you 1 by s f of s, and you have this, but here you don't have derivative. Here it is initial condition without derivative. Here you'll have derivative. Okay. Now let us apply some of the problems to some of the, because this live sessions are basically for the problems I need, and it's also interactive. So interactive means it should be interactive. Okay. I want answer for this question. Okay. You have f of t square. Now find Laplace transform of f dash of t. You can directly do, okay, it's 2t. So 2t 1 by s, 2 by s it will be. But what if we want to go with the formula? S of fs minus f of 0. Isn't it? Now tell me. Hmm. So this is the steps. So you have Simple f0 of 0 is 0 because it is not following an initial condition. So ft is equals to t square as we have the function ft. So fs is equals to 2 by s cube. I this comes up with the ft. It is not t, it is t square. So it is 2 by s cube. So simply 2 by s cube is multiplied with s of fs. So answer will be 2 by s square. You guys can take a screenshot. You just have understanding how it is. Hmm? I want answer for this. If ft is equals to sine 3t, find Laplace transform of double dash of t. We will use double dash now. Give me the solution. Give me the answer. Anyone? So how to proceed with this type of problem? So you know Laplace transform sine of 3t is what? 3 divided by s square plus 3 square divide is equal to that is equals to 3 divided by s square plus 9. Isn't it? Now double dash of t. So it is multiplied with s square. Okay, and sine 0 of 0 is 0. So ignoring the initial condition. So multiplied by s square minus s of fs0 minus f dash of 0. It was the formula. So you are multiplying with s square. So what is that? 3s square divided by s square plus 9. For detailed step, please refer this. Okay, that is a trick here. So it's not a simple problem, first of all. Yeah, it's very great problem. So I just told wrong to tell you to know that whether you are agreeing with my point or not. So you all of you agree with my point. Okay, and f dash of 0 will also be 0. Why? You have to find it. No, see here. So f double dash of t biologically it is this. Okay, so in order to find this, it is minus 9 into 3 divided by s square plus 9. It should be minus 27 by s square plus 9. But what answer I told you? What answer I told you? I told just a 3s square divided by s square plus 9. Is it matching with this? Obviously, no. Obviously, no. So we have to just do that. So let us do this. Okay. F dash of t is equals to 3 cos 3t. Where if you put 0 here, it is 3. Okay. So it is going to 3s square divided by s square plus 9 minus 3s square minus 27. Okay. So s square square goes minus 27 divided by s square plus 9, which is matching with this. Okay. Very nice. So we have this property. An example. This is very simple. So if ft is this, okay, so you have to find integration of f tau t tau. Why can anyone say me that why we are integrating with respect to tau, not t? See, if you are integrating with tau and you have limit in t, then you are getting the functioning time of t. That's why it's very important. If it is in t, then you will not get the function of t. That is very, very bad. But that we don't want. Okay, that's why it is. Now, what is the problem here? So, integration of 0 to t, it's remember, it's 0 to t. Okay, integration of 0 to t, e of 2t, t tau. Integration of 0 to t, e of 2 tau, t tau. Laplace transform of it is just 1 by s into s minus 2. Let us check. Yes. So far, any doubt? Please tell. I'm here for your doubt clarification. So far, any doubt? Okay, no doubt. But in time domain, if you convert here, let us verify with this. Okay. 1 by 2 it is coming, and it is s minus 2 minus 1. So it is 1 by 2. It is 1 by 2. 1 by s minus 2 minus, okay, so 1 by 2 s minus 2, 1 minus s plus 2. Okay, this is equals to, let's keep it here. Where is it? So it is giving 1 upon s square times 2s. Okay. Next example with initial condition. So you have even this problem. Solve for ft using Laplace transform. So you have this f of 0 is also 1. Okay. Tell me. Any idea? One way to solve it is convert it to Laplace transform. Okay. So let me do that for you. Let me solve it here. In order with the step. Okay, we have step also that we can go through that. So Laplace transform of f dash of t, as we know, is sfs minus f0, which is equals to sfs minus 1. So sfs minus 1 will be respond to this particular part. Okay. Whereas 2 of fs is nothing but this part. Whereas 3 to power 2t is nothing but this part. And by solving all those things, you'll be getting fs is equals to s plus 1 divided by s plus 2 divided by into s minus 2. So let us solve using partial fraction. Okay. So it is can be written as 1a by s plus 2 plus b by s minus 2. Okay. So solving will be giving you a and b value. Whereas a you are getting as 1 by 4. B you are getting as 3 by 4. So fs is equals to. Did anyone verify? I want ft from this expression. It's very, very simple. I want ft from this expression. So waiting for the comments. So it is very simple. It is 1 by 4 e power minus 2t ut plus 3 by 4 e power 2t ut. So it is minus ut 2t and it is also plus 2t. Okay. So let us see. And to verify also, you can verify like this. Very correct. So before you opt for the option, please verify like this. Refer this. Okay, let's move to the next topic. Causality and the RFC. Okay. So as we know, our system is called as a causal if ft is equal to 0 for t less than 0. And region of convergence for a causal signal, the ROC is typically a vertical line in the complex plane. Okay. And it should be greater than equal to 0. Like it should be the rightmost side of the rightmost plane, rightmost pole. Okay. Or stability if all the poles of its transfer function have negative real part for the continuous time. And from the ROC from last class, what we observed is if J omega line is there in the ROC, then it is a stable. So it's very causal explanation since it is SNCFT is causal, the ROC is to the right of the S is equals to A, as I told, it is right. Stability condition, if A less than 0, so real part of the pole is negative. So not stable. So let us have the poles and the stability criteria. What is that? So suppose you have poles of Fs are the values that make perimeter 0. So Hs is equals to 1 upon S plus 2 into S plus 3. So poles is equals to, you have poles at S is equals to minus 2 and S is equals to minus 3, both negative real part, which is leading to stability. Okay. If there is any pole with real of S is greater than equal to 0, the system is unstable for continuous time. So suppose you have causality and the stability of the system. So H of S is equals to S plus 1 divided by S minus 2, S plus 2. So poles are there at and system is unstable because so simple logic I will tell you. Like if the ROC, will just draw the ROC. If the ROC, if this line is coming, then the system is stable. And if the causality is rightmost side of the rightmost pole, like it is this side, then it is causal. So since if we draw the ROC, so you have S is equals to minus 2 and S is equals to 1. So you have minus 2 here and 1 here. Okay. So you have uh, And ROC is also the common, always the common part. So ROC is like this, S greater than 1. Okay. So it is not involving this axis, so it is not stable, but it is the rightmost side of the rightmost pole, so it is constant. So Bibo stability means all poles have the negative real part and are simple poles. Where the interpretation can be if any pole is at the rightmost pole or the imaginary axis, the system is not stable. Physical interpretation is what the system output doesn't depend on the future inputs. And for the bounded inputs leads to a bounded output. Pose in the right half plane that is giving the exponential growth that is unbounded output. So there are some summary for the causality and stability. I hope you have solved for this function h of s, y of s, and divided by s of s. So the solution is simple. It is 1 by s plus 3. And step in response example are this. So if you have xt is equals to ut, then x of s is equals to 1 by s. So y of s is equals to x of s into x of s is equals to 1 divided by s plus 3 into 1 by s. So y of s is equals to 1 upon s plus 3 into s. So if you solve for a and b, you will be getting a is equals to 1 by 3 and b is equals to minus 1 by 3. And you'll be having this. So steady state response will be like if t tends to infinity, you're definitely 1 by 3 e of minus 3t is 0. The plenary thing that you can do. So any doubts so far? Impulse response. So if x of t is equals to delta of t, x of s is equals to 1. So simple x of s, y of s is equals to h of s into 1. So the impulse response decays exponentially with rate 3. There are some Bode plot and frequency response if you want to know. I'm not detailing this a lot, but still I'm giving you some seconds for you to explore if you have some doubt, because I got some doubts regarding this. Okay, just telling you in some words. So the magnitude of phase can be plotted, but typically this is standard first order low pass type behavior. So you have pole at s is equals to -3 that is stable. Why? Because it is in the left half of the plane. So if all the poles are in left half, so it is stable only. And DC gain is 1 by 3 because if you keep omega is equals to 0 and you'll get h of j omega ka value at omega is equals to 0, you'll be having 1 by 3. So summary of example one are the set simple first order LTI systems at y dash plus 3y is equals to x of 3t, x of t. Where the transfer function is h of s is equals to 1 upon s plus 3 and yt is equals to simple 1 by 3, 1 minus e power minus 3t. Okay. So there's some second order system setup. The differentiation equation is given. Find h of s and analyze the response to various inputs. Give me h of s closed form equation. So we have transfer function. We can just take it and it is 1 by s square plus 5s plus 6. So we have both negative parts, so it is a stable system, negative poles. Step response. So just find, let us find the step response. Like if we have xs is equals to 1 by s, that is xt is equals to 1 ut. Let us find that. So solving, you are getting this option. No, none of you are just responding in the chat box. I don't know why, but yes, fine. You will be getting A is equals to 1 by 6, B is equals to minus 1 by 2, and C is equals to 1 by 3. For the details, please refer this. I have solved it for you. So basically, I want to have a an infinite time response. So the infinite time response, this e power minus 2t, why it is 0? Because this behavior is like this, okay, like this, with different uh, magnitude. So it is going to 0. Okay, so it is going to 0. It is going to 0, and this is 1 by 6. So the interpretation is poles at minus 2, minus 3. That is giving to the exponential decay terms. And the steady state value for the step input is 1 by 6. System is stable and overdamped because it is a real distinct poles. Real distinct poles. Let us have this first order RLC or the RC circuits. So because sir usually says this in the class, RLC circuits. Okay, so RC circuit with the resistor R and the capacitor C in series. Voltage with this output across VCT. So we can write the input voltage in terms of RC dVCT by dt plus VCT. Taking the Laplace transform, assuming uh, VC0 is equals to 0, where V input can be written as RC RCS VC of S plus VCS is equals to RCS plus 1. So it's simple. X of S you'll be solving and will be getting is 1 upon RCS plus 1. Why I'm telling it's simple exponential, and exponential will be 1 upon e power minus 1 by RCT. So HT is nothing but 1 upon RCT. So partial fraction, solving it, you'll be getting VCT is equals to 1 minus e power minus RCT, T by RC. So for the steps, you just see this. Okay. So finally, VCT is equals to 1 minus e power minus T by RC. Where if a steady state response is simply 1 into Vn of DC. So similarly, RL, I want you to solve for the RL part, the resistive and inductive part. Okay. Just give me the closed form equation for that. So I want closed form equation. You can just solve the C example problem with RF. Uh, So basically, the summary of first order RLC is what? The circuit's voltage or current typically satisfy a first order ODE, and the transfer functions forms 1 upon tau s plus 1 or alpha divided by s plus alpha. Okay. The step responses are exponential in nature with single time constant. That is that. Okay. The simple series RLC circuit I have told you of several times, so I'm skipping here. You can have just an overview of it if you want. Forming the differential equation. You have final form as LC square. So it is a second order term, okay, with the RC as first order and LC as second order. Naturally, frequency damping and all. So if we define omega naught is equals to 1 upon root over LC, okay, and eta is equals to R by 2 root over C by L. Then LC is S square plus RCS plus 1 is equals to 1 upon omega naught square S square. So this is a standard second order form. And giving you the overview, step response overview. It's actually very, very important for you to understand. So depending on the damping, you will get the overdamped, critically damped, and the underdamped responsive in the time domain. So underdamped, where theta is less than 1, where we see t is equals to 1 upon this part, and omega d is equals to omega naught, root over root over 1 by 1 minus theta square. So that's great to know. And here you are having omega d here. Omega d here. Okay. And this is theta divided by 1 minus theta square. This is damping factor. With some example numerical values, I would like to give you some underdamped case where underdamped means it is less than 1. So theta is less than 1. So you're having suppose 0.5 and omega naught then 2 rad per second. It is giving theta is 0.5 because we have R as 2 ohm, H as 1 Henry, C as 0.25 farad, step response is 10 UT. Okay. Then omega naught using this formula, root over LC. Omega naught is root over LC. And theta is using this formula. What is the formula for theta? Just it's 2 by R root over C by L. Yeah. So theta is having this formula. Theta is equals to 2 by R root over C by L. And you can solve also. But in this case, it is. Okay. So what are the summary? Okay, the governing equation is LCVC double dash RC V dash of C plus VC is equals to be input. The transfer function is 1 upon LCS S square plus RCS plus 1. So response depends on the damping ratio. Okay, if you want this over damp, so it should be greater than 1 in that case. But generally for the stability, we consider the underdamped case that is between 0 to 1 and over under critical rate. Critical damped zeta is equals to 1. But distinct transient behaviors will be observed. Now we'll solve some of the problems for the next 20 minutes. Then we will end the sessions. Okay. Based on the things that I taught you, I would like to have some of the interactions from. The question states that so. So what is that? The question one states that the region of convergence, the ROC corresponding to Laplace transform of x of t is equals to ut per minus at is what? Is what? It's simple. It's greater than a minus. How? Because you have x of s is equals to 1 upon s plus a. And the ROC states that s greater than minus a. So answer is this. Okay. So for the correct response, I would like to give you like this solution. So it's I feel very painful to prepare such these slides with all the steps and equations. So if you have any doubt, just let me know. But still, I prepare for you. So yeah, if you have any doubt, you can just let me know. The solutions I prepare by myself. So okay, so I think you might have got this. Okay, next problem. The Laplace transform of x of t has only one pole at uh, 2 minus 2 plus 2, two poles at this one and two poles at this one. So what is the obvious answer? Xt is defined previously only with the previous question. That's for sure. It's only one pole at t of s is equals to minus 2. So correct answer is this. C. How? Because you are having, sorry. Because for the question, it's my mistake. I didn't type it well. So h of s was given. So for this h of s, it's obviously this. Okay, how many different LTI system can have the transfer function? The transfer function is defined like this. Okay, so how many LTI system can have the same transfer function? What do you think? Okay, so answer is two. Why? Because LTI systems are transfer function. First of all, if we give you the figures normal step, system represented in time domain, then the simple impulse response can be represented differently while maintaining the same transfer function. Two systems can have the same identical transfer function. Conclusion, a two different LTI system can have the same transfer function. This is a very valid question. So your answer is two different, or the two systems can have the same identical transfer functions. So question number 4. So given, That is question number 4. Okay, this was the question number 4. Given the signal ut, you have to find the region of convergence. Okay, so xt is equals to e power ut into e power minus 1 plus 8jt. So first of all, we have to find it on Laplace transform. So x of s is equals to 1 upon s plus 1 plus 8j. Why? Because it is e power minus 80. So a is here is equals to 1 plus 8j. So how to find the region of convergence? Simple. S should be equals to real of, here the trick is should be real. Real is 1. Okay, so S should be greater than minus. Because why? Because S plus 1 plus 8j is equal to 0. So S is equals to minus 1 plus 8j. Since it is real of this part is 1 minus 1. So it is minus 1. Very good question it was. So that's why I have added here. Question number 5. So, okay, I will explain you the question, then you will tell me the answers. So for the Laplace transform of x of s is equals to 1 upon s plus a, assuming a greater than 0. What is the x of t for the possible ROC? Very simple it is. What will be the answer? Answer is very simple. It is u of t power 8 minus 80. U of t power minus 80. Why is minus 1? Why it's minus 1? Answer is minus u of t power minus 80. Because there is a solution. Okay. Should not be plus 1 x of s is 1. Okay, so the function represented again exponential for the causal function. Okay. So figure 1, I didn't prepare figure 1, so you can delete this question. So in order to have the figure solution, you have to follow these steps. Go through this ones. Okay, you can go through this. For the Laplace transform HFS, assuming RLC value given, what is the region of convergence? So yes, this is a strange question and good question. What will the region of convergence? Okay, so answer is minus R divided by 2L. Why? Because we have to go through like this only. We analyze the system post using standard Laplace transform methods, compute the solutions based on RLC circuit values, and then we have to identify the stable ROC. And the conclusion ROC is minus R by 2L. If you have doubt, you just pin me here. I am waiting if you want to know the answer. This pin me. Otherwise, you can just we will move to the next question. Okay, what is xt for this e power minus ATUT? Sorry, AT here with definitely my A is minus 1. Question number 9. What is xt figure I didn't kept? So for that, if you have given a figure, use the inverse Laplace transform to express that in time domain function. Step 2 is to identify or recognize the effect of exponential decay and the step functions. Then verify the ROC constraints for the valid interpretation, and you have this. Again, the same intuition. So we have seen the concepts through several examples, not only one, two, three examples. And finally, we saw some of the 8 to 10 questions, out of which I skipped some of the questions because of some figure degrees. But yes, so I hope you can solve all the problems related to this, and you don't have any issue in that. Okay, and if still have issue, you can mail me. I can still see I there will be some people who used to join my class uh, but this time it's not joining. I think there are 3 TAs working on this. But still, I'm happy to teach. I'm teaching whatever I'm feeling and preparing the questions preparing the PPTs accordingly, perfectly. So this PPT is very, very good. So if you can just have a look at this PPT, which I'm uploading in the Drive folders every week. So that will be really helpful for you, even if you don't want to join my class. And still, the other thing that which I would like to say is don't give up easily, uh, because that really matters a lot for us. If you have, suppose if you have taken suppose this subject. So please don't give up. People generally give up at the last moment. I'm still here. If you have some doubts, you can just ask me. I'm waiting for you for the 5 minutes. Then I will leave this meeting and put the recording in the YouTube video. This slide was most underrated as of now. So if you want to go through that, please go through my slides. So I'm ending this session now. Okay. Thank you so much for joining.